All right, my friends, this is for those of you who have this disposition. I am not technical. I am not technical. Help me. Help me, Phil. What am I going to do as I apply for jobs? I'm not technical. Where do I even start? More important than being technical is being mindful of the more important pieces of project management. So not being technical is important to address, especially if you're going into a tech kind of job as an IT project manager. But I want to emphasize that your emotional intelligence is really important, because the way you relate with people of a technical nature, like the development people, the testing people, right? The coders. Without EI, you cannot work effectively with them. So even if you got all the technical savviness and you're not able to employ EI, you're not able to observe nonverbal cues, you'll not be able to work well with those people. So I want to make it clear, coming in, EI is important. With EI, I want to give you a context, a framework for you to understand what these projects typically entail. And I want to base this on the software development lifecycle, which is an overarching framework for projects. It stood the test of time and it's still around, right? So if you're thinking of IT projects, there's always going to be an analysis. There's always going to be this. Whether it's hardware, whether it's software, there's going to be a question of what exactly are we trying to do, and what will it entail in order to do this, right? And that's the very first step, analysis. I realized very early on in my project management career that the software development lifecycle was not project management lifecycle. I used to think it was, until I went for an interview and I bombed the interview and I realized this is different. This is what you need to do the work, right? What you need to do to get the work managed is project management. What you need to do the work is this software development lifecycle, or you could call it a life cycle for work, right? To get the work done. So you're going to ask in this section, what is the problem? You're going to analyze, what is the problem? You're going to find out where the problem is, and you're going to attempt to begin breaking down the system into different pieces. Whatever that system is, it could be software, it could be hardware. But coming in, you need to be thinking about breaking down what needs to be done and bringing in users so that you can actually collect the right requirements. Okay, so for you to do well in this first step, you need to have a very analytical mind, someone who is curious, and someone who just can look at a system, look at anything, look at a phone, look at a device, and break down the device as far as, okay, what makes this work? What makes it valuable? What makes it useful to the customer, and things such as that. After analysis, the next thing you want to think about is design. Okay, remember, this is broken down for people who feel they are not technical, because I want to show you the confines of an IT project, if you will. Whether you're working software or you're working hardware, there could be subtle differences. There could be customizations in how the life cycle flows, but for the most part, this will help you. So the next one is design. And in design, we are thinking about the design functions and operations of the system. What will the layout be? What will the business rules be? Business rules are very important. They're quite huge, especially when you're working on enterprise type of tools. So I'm going to put a few buzzwords here for you to think about. So you're thinking about operations of the system. You're thinking about business rules. You're thinking about process diagrams and other relevant documentation. So in order to do a good job with the design stage, you really must have done a good job of the analysis, which is known the requirements. You can't do a great job of design when you don't know the requirements. So we're going to take the requirements that we talked about in the analysis stage. We are going to analyze what the customer wants in the analysis stage, but in the design stage, you're going to design what the implementation of those requirements will look like. So you're going to describe the desired system or the future state. You're going to define what the future state will be by great design. And you got to remember, people in the world of IT are broken down, if you will, by skills. Some people are great at the analysis. They're not all that great at the design. And some people are phenomenal at the design and not so good at the analysis. So you got to understand this is not a one-person thing, even though one person could do all, but it's not a one-person thing. Okay, so design elements are going to help us understand the desired features and how they will look. We could build different imagery, different diagrams, screen layouts in the case of software to show how this might unfold. Okay. Then we get into the actual development. And again, it's another skill. You got some people who are excellent coders. They can code whatever you design properly, but they are not good at design. They're just great at taking a design and developing a solution based on the design. Okay, so this is where the team builds out the solution based on the design. Okay, so I should probably rephrase this. I got so carried away with the actual people. It's actually development. So, or develop, if you will. So let me redo that. This is develop. Analysis, design, develop. So the team builds out the solution. Usually this is done in an environment where they are building stuff out, maybe by trial and error at times, making mistakes, correcting those, and doing things in cycles. When all is said and done, you're going to get to a stage known as test. Everyone knows test because we might have even been part of a test team ourselves. And this is where the code is tested. So I'll just put test the code. You're going to test the code. If it's not code, maybe it's a hardware system itself. You're testing the integration, you're testing something, right? And there are all sorts of testing. You could go read some of these up. There's unit testing, system testing, integration testing, black box testing, white box testing, regression testing, automation testing, user acceptance testing. We could go on and on talking about different testing, but the bottom line is a test needs to be done. All right, so you're going to test the code or you're going to test the solution. The final thing when you've done your testing is implement. And you implement when everything has been found to be fit or good to go. So let me use my red marker to show you. So if you're working on in an IT environment, you'll be sure to do analysis, design, some sort of development, some sort of testing, and some form of implementing. Now, for those who are involved in the afterlife of a product, beyond implementing, you could have, and I'll just put here M for maintenance. That could be another piece of the puzzle that happens after you're done with the project. But I don't want you to think maintenance is part of the project, because no, remember, the project ends at implement, and what happens next is it could be a maintenance stage. Okay, and that's it, my friends. I just wanted to give you a very quick idea of how the world of IT works, and a great way of you getting your arms around it is by understanding the software development lifecycle. Okay, if you have any questions, make sure you put them in the comments below. Bye for now.